The first challenge we face is omitted variable bias. This occurs when relevant variables are left out of a model, yet they are correlated with the policy being studied. In other words, these omitted variables influence the outcome variable and are also related to the policy dummy variable. For example, consider a model that uses a dummy explanatory variable, chain, to indicate whether a worker has received job training. This variable equals 1 if the worker was assigned to job training and 0 otherwise. When we regress the log of real earnings on the training dummy variable, we find that the slope estimate is 0.18 with a p-value of 0.129. This indicates that the effect of job training on earnings is not statistically significant at any conventional level below 12%. At first glance, one might conclude that there is no causal relationship between job training and earnings. However, a close look at the racial composition of workers who received job training reveals a different story. Using the tabulate command followed by the gray and black variables allows us to create a two-way table of frequencies. If we examine the table using the row option, we find that among workers who did not receive job training, 79% are black. Among those who did receive training, 97% are black. This highlights a systematic difference in the racial composition of workers with and without job training. When we add the dummy variable black to the model, the estimate for job training changes dramatically. It rises to 0.30, much higher than the previous estimate. Importantly, this result is statistically significant at a level as low as 1.6%, indicating strong evidence for the impact of job training on earnings. Workers who have received job training earn 30% more than their counterparts who have not, when controlling for racial factors.